Questions 6 through 11. Listen to part of a lecture in a geology class. The professor is talking about plate tectonics.
Plate tectonics is the theory that the Earth's crust, the rocky part of the Earth, is composed of several large, rigid plates. These plates are being created at some edges and being destroyed at others. They're also moving across the Earth. The theory of plate tectonics was first put forth in 1963 by a Canadian geophysicist whose name was Tuzo Wilson. Tuzo Wilson was instrumental in advancing the theory of plate tectonics. He suggested that Hawaii and other volcanic island chains might have formed as a result of the movement of a plate over a motionless hotspot in the Earth's mantle. Hundreds of studies have proved that Wilson was right. However, in the early 1960s, his idea was considered so radical that his hotspot manuscript was initially rejected by all the major international scientific journals. Since that time, plate tectonics has come to be the main theory in the earth sciences, and it forms the basis of our understanding of the development of our planet. The theory of plate tectonics and the discovery of seafloor spreading confirm the earlier theory of continental drift regarding the movement of continents. Basically, tectonic plates are areas of the Earth's crust that move as a unit. At the present time, there are 8 large plates, as well as a similar number of smaller plates. According to plate tectonics, a plate has 3 kinds of boundaries with other plates: oceanic ridges, oceanic trenches, and transform faults. Okay, you've all read the chapter on plate tectonics, so you know that a couple of things can happen at plate boundaries. For example, what? Yes, Heidi?
Rock is sometimes forced up the mantle in molten form as lava at ridges in the ocean floor.
Yes, that's right. Lava flows up as underwater volcanoes along oceanic ridges. Good. What else can happen at plate boundaries? Travis?
In trenches, in hot spots, rock can melt and it can slide back down into the mantle.
Yes. And do you remember what we call that?
We call it subduction.
Correct. Subduction, the process of rock being swallowed or forced back into the Earth's mantle. During subduction, as one plate dives into the depths beneath another, we think part of the rock melts and eventually finds its way back to the surface in the form of volcanoes. In fact, most of the world's volcanoes and earthquakes occur at plate boundaries. This is what you'd expect because plate boundaries are where a great deal of friction and stress occur. All right. At plate boundaries, what we find is, that is, in the areas around oceanic ridges, the deep seafloor is formed by the rising lava, which then spreads out sideways in both directions. Seafloor spreading was discovered first in the North Atlantic, and soon afterward in all other oceans.
Excuse me, Professor Nash?
Yes?
Does the spreading of the ocean floor mean that the surface of the Earth is increasing?
No, it doesn't. Seafloor spreading does not cause an increase in the Earth's surface because, and this is important, because the lava that rises and spreads from the oceanic ridge sinks again somewhere else. That is, in a subduction zone. And as we've said, subduction zones usually undergo frequent earthquakes. Subduction zones are also associated with rows of volcanic islands that usually accompany oceanic trenches. Subduction is currently happening beneath island arcs like Japan. It's also taking place on the northwest coast of North America. This is where a subducted plate is thought to have disappeared beneath the North American plate in recent geological time, leaving the volcanoes of the Cascade Range as evidence of its past existence.
Number 6. Why does the professor talk about Tuzo Wilson? Number 7. Listen again to part of the lecture. Then answer the question.